Okay, so we have two more parts to finish on this problem. The first part is part C, and they want us to find the x-coordinates of each point of inflection. So as we were saying at the last video, we will set the derivative equal to 0, and our second derivative is this 4x squared minus 2 times our e to the negative x squared. As we set that equal to 0, we will use the zero product property to solve for x. So 4x squared minus 2 is equal to 0, and we would also set e to the negative x squared equal to 0. Before we rush off and solve, I want you to think a minute about this side. And think at first, is it even possible to have e to something equal 0? Immediately you might already see that that's an impossible situation. There's no solution there. If you don't think about that right away, we could take algebraically, we could solve for x here by just taking the ln of both sides, since it's an e. So if I take the ln of e to the negative x squared, if I'm taking the ln of both sides, we would have ln of 0. And here's where the problem is. That's an impossible situation. If you think about the graph of the ln of x, we have a vertical asymptote at 0. So we cannot plug in 0 in for x and receive an answer. There is no solution there due to the vertical asymptote. So here, this side would be no solution, so the only solutions that we have to think about is here. And this is a nice, easy problem to solve. I'll just add 2 to both sides, then divide by 4, and we'll have x squared equals 1/2. Now we're trying to get x by itself, so we will take the square root of both sides. And remember, when we take the square root of both sides, our values could be 2 negatives times each other or 2 positives. So we'll have the plus or minus the square root of 1 over 2. The square root of 1 is 1, so we have plus or minus 1 over the square root of 2. So here's our two values. So there's our x-coordinates of each point of inflection. And now we want to use the second derivative to show that one of these points is a point of inflection. So we will do that by showing a sign diagram. And says to use the second derivative, so we'll use the second derivative sign diagram. Our first point of inflection is at -1 square root of 2. It's our least sign, so we'll go from negative infinity to -1 over square root of 2. Our next one is 1 over the square root of 2. So our next interval that we'll test is -1 over square root of 2 to 1 over square root of 2. And our last one would be 1 over the square root of 2 to infinity. Okay. So this is on the paper 2. This kind of a test question would be on the paper 2 exam, so you would have your calculator. So a couple things you could use if you forgot some of this knowledge is you can try to graph this. The only problem is this graph is a little bit confusing when you go to look at it, so you would also want to think about the natural log. And second of all, you could, if it helps you, use your calculator and to find a decimal. If you plug that in, it'd be plus or minus 0.707. So that, when you go to test, helps you pick good values to test. And in this range, I'm going to go ahead and test a -1 into my second derivative. And when we plug in here to my second derivative, -1, we will get a positive number times another positive number. So here is positive. Then I would test a good number in between this, in this range would be 0. I test that into my second derivative, and we have 0 minus 2, and e to the 0 would be 1, so we would get a negative number, because it would be -2 times 1. And last, we would test in maybe a +1 would be a good one, and that again would be a positive value. Alright, so what this is telling us with the second derivative is concavity. So here we have a concave up, here we have a concave down, and this section would be concave up. So when you go to look at your graph to make sure you proved it right, it should correlate with what your graph is. Yep, from this section to here would be concave up, and then from here to here would be concave down, and again concave up. Lastly, we would write that because of the sign is changing, the signs here change, we've shown that there is a point of inflection. Okay, so you could write it twice to prove both of them. The last thing I want to show you is just the mark scheme. If you look at this original problem, we can look at how the mark scheme is worked. And you can see that there's this accuracy points sometimes, and then there's method points. So here with our first section, we had accuracy points. And then here we had a method point would had to be choosing the product rule would be 1 point. There's also reasoning points, so you have to show a valid reasoning. So you would have to show that second derivative equal to 0, and then the method would be attempting to solve the equation. Okay, and our last part here is you want to show the evidence of using the second derivative to test the values on either side. So finding values reference to the graph and sign diagram correct. Lastly, that would be 3 of the points. The last would be showing reasoning. You would have to state that on either side you have to reference that the sign changed, and that's what makes it a point of inflection. Okay, so that's the last of the notes today. Just 2 IB questions applying applications to our exponential and natural log functions. Have a great night. We'll see you tomorrow.